Alright, so we are using ClassKick again for notes. So once you hit that link in Schoology, it should bring you to something that looks like this. Make sure that you're scrolling down. You'll notice there's a note at the top. I put today's notes at the front of your ClassKick, and so you still have all of the same slides that you did the other day. All of your notes are going to be housed here. So slides 1 through 3 are our notes today, and then you'll see slide 4 says that you're finished. But make sure that you scroll through and scroll down all of those when you're completing the notes. So I'm going to go to OneNote. It's the same thing as what you have, except that I can write on it. And so we're doing 15.6, which is the converse of the Pythagorean theorem. And so what is a converse? A converse is switching the hypothesis with the conclusion. So just like in science class, when you have a hypothesis, the same thing as in math class. And so, for example, if it is raining, then the grass is wet. So this first statement is our hypothesis, and then our second statement is our conclusion. Sorry, that's supposed to be a C. So when we switch it, it says if the grass is wet, so that is our conclusion comes first, then it is raining. So that's our hypothesis. So another example would be if I live in Parkville, I live in Missouri. And so our converse is if I live in Missouri, then I live in Parkville. So you'll notice that when I had the converse, so these two right here, when we did this, it actually is false. And so it doesn't make a true statement. Just because the grass is wet doesn't mean it rained. It could have been sprinklers, right? And same thing, if I live in Missouri, it doesn't mean I live in Parkville. It means that I could live in anywhere. I could live Kansas City or Gladstone or wherever. So I want you to write 2 of your own converse statements, and then let's continue with notes. So the Pythagorean theorem, we learned this the other day, but I'm going to go through it again because it's been spring break and a lot of us kind of tend to forget some things over that time. And so when we have a right triangle, we have 2 legs, and those 2 legs are always the 2 sides connected to that right angle. And then the hypotenuse is our side length that is across from our right angle. And so we're going to do a quick example. So remember that the Pythagorean theorem uses this formula, and so we are going to plug in our legs and our hypotenuse to that formula. So remember, C is always our hypotenuse. Our legs don't matter which one we call them, A or B. That part doesn't matter, so we can just assign whatever we want to that, A or B. So let's plug it in. So A we had as 5 squared plus 12 squared equals C squared, because we don't know what C is. And then we're going to square them. So we have 25, because we just do 5 times 5, plus 12 times 12, which is 144, equals C squared. And so now add them together. And so we get 169 equals C squared. And then to find what C is, we need to take the square root. And whenever we take the square root of something squared, these two cancel out. So it just leaves us C equals whatever the square root of 169 is, which is 13. So we know that this side length is 13. So I'm going to have you try this one on your own and then check your answers with mine. All right, so you plug in your A, B, and C. And so we have A squared plus 2.1 squared equals 2.9 squared. And then I squared both of those, so I did that number times itself, and that gives you 4.41 and 8.41. Before we can solve for A, we need to get A alone, so we're going to subtract 4.41 from both sides, and we get A squared equals 4, And then to figure out what just a equals, we take the square root and that cancels these two out. And so we get a equals 2 because 2 times 2 gives us 4. All right, so now we're going to look at the converse of the Pythagorean theorem. And so what's kind of cool about the converse of the Pythagorean theorem is up here, our conclusion, once we switched it with our hypothesis, it was false. But the Pythagorean theorem, when you switch it, it still keeps a true statement. And so it says if an equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then the triangle is a right triangle. And so what we're going to do is prove that these are right triangles. So we are going to plug in our values into a squared plus b squared equals c squared. And so remember, our right angle across from that is our c. So then our legs, it doesn't matter which one we want to do for A or B. Our C is always going to be the largest. So that's also another way to help you out on your homework. Our C value is always our longest value. So now we're going to plug those in. So 9 squared plus 40 squared equals 41 squared. And so we know 9 squared is 81 because 9 times 1, 9 is 81. 40 squared gives us 1600 equals 41 squared, which is 1681. And so now we're going to add this side together. So we are going to see if this side that I highlighted equals the other side. So when I add 1600 plus 81, we get 1681, and that equals the other side of 1681. So we know that yes, it is a right triangle. All right, so I'm going to have you, no, let's do this one together. Let's do one more for practice. So a squared plus b squared equals c squared. And so it looks like our longest value is 24, so that's going to be our c. And then these two would be our a and our b values. And again, our legs don't matter. A and b can flip and it won't hurt our equation. So we have 12 squared plus 18 squared equals 24 squared. So we have 144 plus 18 squared. And we get 324 equals, and then 24 squared is 576. So let's add this side together and let's see if we get the same thing. So we are going to add, stop. Sorry, that was my dog. 144 plus 324, and that gives us 468. So 468 should have equaled 576, but it does not. So not, and I'm going to do the right angle sign. So not a right triangle. The thing is, on this picture, you can kind of tell that this is not a right angle. That's not always going to be the case. Sometimes they purposely draw it to look a little odd just to see if you actually solve it correctly. So make sure that you still solve it and don't go by just the picture. So I'm going to have you try the try-its, and then you are going to check your answer with me. So check your work with mine. You'll see that I labeled my A, B, and C in each problem. Your C is always your largest number. And so that's how I knew how to set up the 28 on this side and the 1.25 on this side. For number 1, we got that they are not right it is not a right triangle. And for number 2, we got that it is a right triangle. All right, example 2. So tell whether the points form a right triangle. So first we need to graph it. I don't know if they'll provide a graph on your homework. If they don't, just use your piece of notebook paper and you can graph it out. But you are going to first plot your points. Oops, don't want that. Made it bigger. All right, so that's 1, 1. Go over 3, up 5. and then over 3 up 0. So we are trying to see if this is a right triangle. So first we need to find the distance between each point. From here to here, we have 5 is our distance because we can actually count those. So now we need to figure out the distance here on this side. And so we are going to use this right triangle to figure that out. So we know that there's 2 here and 1 here. And so we have 1 squared plus 2 squared equals c squared. And that will give us that line that we are trying to find the bottom of the triangle. So 1 plus 4 equals c squared. So we have 5 equals c squared. And so now we're going to take the square root of both sides to get rid of that floating 2 and that exponent. So we have square root of 5 equals c for that one. So then now let's find the distance from here to here. And so we're going to use this triangle. And so we have 2 and 1, 2, 3, 4. So we have 2 squared plus 4 squared equals c squared. So we have 4 plus 16 equals c squared. That's 20 equals c squared. We're going to take the square root. So we have the square root of 20 equals c. Now let's see if it's a right triangle. So this highlighted one, which we found was 5, that's our c. And so we have to see if we take 5, square root of 5 squared plus the square root of 20 squared and see if it'll give us what 5 squared is. So remember when we have a square root and we square that, those cancel out. So we have 5 plus, those cancel, and we just have 20. So we just keep what's inside. That's going to be on your homework. And then 5 squared is 25. So 20 plus 5 is 25. So yes, it is a right triangle. And I'll have you do the try it on your own and check your answer with mine. All right, so I tried to color coordinate as much as I could for you guys. I found the distance between, well, that formed a right triangle in black, and so that's 3 squared plus 3 squared equals c squared, and I found that c equals the square root of 18. And then when looking at this side right here, I found that that is the square root of 13. And then I set that into I put both of these into the Pythagorean theorem as well as my 5. And remember, your 5 is always your longest side, so we knew that this was c. And so 13 squared plus, or the square root of 13 squared plus the square root of 18 squared equals 5 squared. So when we square something that's taking the square root of, those cancel out. So we have 13 plus 18 equals 25, and it actually doesn't. It equals 31, so it is not a right triangle. So the modeling in real life is done the exact same way. So I am going to quickly do this on my own. It'll pop up quickly on your screen in 1 second. All right, so you'll notice that the only difference with this one and the last problem that you guys did was you had to find the distance of all 3 sides. And so you do the exact same thing that we just did in the other problem. The only difference is you have to do it 3 times instead of 2, and that's why I didn't want to take a whole time going through the whole problem because we've already done it. So then once I found my C values of each of them, which by the way, it said in here that each grid mark represented 2 feet. So even though I only met 3 grid lines here, it's actually 30 because you have to multiply it by 10. So that was also something that's a little bit different. But once I plugged it into my a squared plus b squared equals c squared equation, my squaring of the square roots canceled those out. And so you just take what's inside of your square root, and that gave you 18,000 plus 5,000, or 1,800 plus 5,000, and that does give you 6,800, which makes it true. So yes, your friend ran it correctly.